Welcome, and we are going to talk about distance problems. Let's just get our bearings and talk about speed limits and the rate that you go in the car. We're probably familiar in our country with 25 miles per hour or anything miles per hour. Kilometers per hour, you might see abroad, but in our country we do 25 miles per hour. So, what does that mean other than, yeah, that's a speed limit you go in front of a school? Well, it is a rate. So that's important that we're aware of that. That is a rate. So it's how much distance you travel per unit of time. So what that means is a rate has something to do with distance and time. So going 25 mph is 25 miles per hour. So 25 miles for every 1 hour. So that means if you're traveling for 2 hours, the distance you cover is 50 miles. If you're going 25 miles per hour and you travel for 3 hours, the distance you cover is 75 miles. So you might notice that if you take the rate and multiply it by the time, you get, that's right, the distance. So D equals RT is a formula that you're going to want to remember. The good news is, if you forget it, you can just do these types of examples and remind yourself. So let's say we're going 10 miles an hour, and we're going 10 miles an hour and we are traveling for 2 hours. So distance equals rate times time. So 10 miles an hour times 2. So we would be going 20 miles. What if we were going 10 miles an hour for 30 minutes? 300 miles? No. 30 minutes is just half of an hour, so you have to realize what units you're in. It's per hour, so 10 miles per hour times half of an hour, so you'd really only travel 5 miles in 30 minutes when you're traveling 10 miles per hour. So again, D equals RT. That's what you're going to want to remember. So we'll be using variables and we'll be relying on this equation. So consider this. A plane travels 550 miles per hour. That's pretty fast. Represent the distance it will travel in h hours. So the distance it will travel in h hours. So it's going 550 miles per hour times h hours. That's going to give us the distance. So if a car travels for 5 hours at r miles per hour, represent the distance it traveled. Okay, so it's going for 5 hours, that's the time, and its rate is r. So there's the rate. So 5r. That would be representing the distance this car travels going r miles an hour for 5 hours. All right, a ship sailed t hours at a rate of 22 miles per hour. Represent the number of miles sailed. Okay, so the number of miles, or the distance, would be the rate, 22, times the time, so 22t. Okay, with that in mind, let's move on. So we have this label box here. We got Romeo and we got Juliet. If you use this kind of setup and a label box, this is how you're going to define your variable. And notice that at the top, I have rate and time. Those will get multiplied, and those will equal the distance. So it kind of sets up that structure of distance is rate times time. Okay, so it helps to draw a picture with these word problems. So after their argument, Romeo and Juliet drove away in opposite directions. All right, so they're going in opposite directions. Romeo drove 54 miles per hour, so I'll put that here. Juliet drove 66. So who would have driven further in the same amount of time? The person going 54 or the person going 66 miles an hour? Correct. The person going faster should cover more mileage. So that would be Juliet, and here's Romeo. The question is, how long did they travel? So after how many hours were they 420 miles apart? So this distance needs to be 420 miles. So the distance that Romeo traveled just this part, plus the distance that Juliet traveled, just this part, need to add up to 420. So this is going to be what's called my skeleton equation. It's just sort of my setup. It's going to what I'm going to drape all my details on. But let's talk about, let's see, what would go under time? Well, it asked me how many hours, so T must be the amount of time. Now, after their argument, Romeo and Juliet drove away in opposite directions. We are going to assume, appropriately, that they left at the same time. All right, now, how do I figure out what the distance that Romeo went? Well, it's his rate times his time, and I'm going to look here. 54t is Romeo's distance. 66 times t is giving me 66t. That's Juliet's distance. So Romeo's distance is 54t. Juliet's distance is 66t. Add them together, you're going to get 420 miles. All right, so here we go. 54, 66. We're going to get 120. So 120t equals 420. So t equals 420 over 120, or 42 over 12. I'm going to divide both by 6, and I'll get 7 halves. So 3.5 hours is my answer. It'll take them 3.5 hours. Now, when you're doing this, you need to approach these problems and earn 5 points. The first one of the 5 will come from your label box, defining your variable. I can tell from this label box that t is the time that Romeo and the time that Juliet drove. Then I need an equation. This is part 2. Then I need you to actually get a solution, and then I need you to make that solution into an answer to the problem, because sometimes the solution doesn't immediately answer the problem. All right, so that's 1, 2, 3, 4. That's 4 steps. My 5th step is to check it in the words of the problem. So if Romeo drives 54 miles an hour for 3.5 hours, and Juliet drives 66 miles an hour for 3.5 hours, is that going to make them 420 miles apart? That's what I need to check. All right, so 54 divided by 2 is going to give me 27. 66 divided by 2 is going to give me 33. So 27 times 7 is going to give me 9 with a 4, 189. 33 times 7 is going to give me a 1, a 231. Add that up. 420. Cool, it worked. So 3.5 hours is my answer. Often I'll ask you to give the answer in a complete sentence. So something like, it will take 3.5 hours to get 420 miles apart. That would be an acceptable answer. And then make sure you show me that you checked it to earn all 5 of your points. Let's try this again. Tori and John want to play a supersonic, galactically long play of catch, or game of catch. So Tori is going to go due west, and John is going to go due east. They decided they would keep going until they were 21 miles apart. Oops, this should be John, not east. All right, so 21 miles apart, and then they're going to play their galactically long game of catch. All right, they left from the exact same spot at the exact same time, so going in opposite directions. So the amount of time that they take is going to be the same. All right, cool. Let's make my picture a little smaller here. So I have Tori, I have John, I have rate, time, and distance. So I'll set up my label box. All right, they left the same amount of time. Tori left going 5 miles an hour, so that's his rate. John left going 2 miles an hour. Cool. How long did it take them to get 21 miles apart? All right, well, I don't know. They left the same spot at the same time, so T is going to be amount of time they traveled. Very similar to the Juliet and Romeo problem. Notice, friends, I am not putting 21 into here because Tori is not traveling 21 miles. Neither is John. Instead, the amount that Tori travels, the distance of Tori, plus the amount that John travels, that's going to equal 21. So no, do not put 21 in here. Where you get this cell is from multiplying these two, because distance is rate times the time. All right, so 5t plus 2t, that's going to equal 21, because Tori's distance plus John's distance, that's going to produce 21. All right, so 7t equals 21, t equals 3, so I want to answer in a complete sentence. So it takes them 3 hours to be 21 miles apart. And let's just make sure that makes sense. If Tori's going 5 miles an hour, he's going to have traveled 15. If John's going 2 miles an hour, he's going to have traveled 6, because 2 times 3, so rate times time. So I'll get 6. So yeah, that gives me 21 miles. So here's my check. Here's my sentence. Here's my solution. Here's my equation. Here's my label box. 1, 2, 3, 4, 5. I get all.